wonderforce.com.
Okay, today we are going to start with the new topic, that is preparation of the alkynes. Okay, so alkynes means wherever triple bond is there, that is called as alkynes. How to prepare the alkynes, and if you have prepared with the lower number of alkynes, we can upgrade to the higher alkynes also. Okay, so let's start with the first reaction is vicinal dihalide. This is called as a vicinal because adjacent carbon and two halogens are there, that's why di, and halogens are there, that's why vicinal dihalides. Okay, by using the first preparation method is by using the vicinal dihalides. So wherever you want the double bond, triple bond to be present, at that place our halogen should be available. So for removing that, we can use the alcoholic KOH and another will be the sodamide. So this is a bit strong removal agent. Strong eliminating agent is the sodamide. First step, we can use the mild eliminating agent like alcoholic KOH also. Okay. So for example, let us take this is the place where adjacent halogens are there. Let us take here, this is one bromine, this is another bromine. Obviously, this place hydrogen, this place hydrogen. Okay. So now first step, when we use the alcoholic, always remember when the word used as a alcoholic will cause the elimination. Alcoholic will cause the elimination. In this place, if I write the aqueous, if in this place, if I write the aqueous, obviously that is going to be substitution. Okay. So as it is mentioned, it is alcoholic, therefore I have to eliminate it. For the elimination, I am marking out here this OH will remove this H. Okay. And I am using the another color. So this potassium is removing this bromine. Okay. So ultimately two things are eliminated. One is minus KBr. Okay. Potassium and bromine. And what else is the next one? The next one is OH and H, that will be H2O. That is going to be H2O. This type of process is called as a dehydrohalogenation. The name itself will tell you everything. So D means removal and hydrohalogenation means one hydrogen, one halogen is removed. So because of this, what will happen? There will be a double bond between them. There will be a double bond between them, C hydrogen, and there will be a double bond CBr, and it is a present. Okay, this is the step one. The complete mechanism wise I am saying you. So mechanism in this step one I have completed, where I have used the alcoholic KOH. In the step two, I will be using the sodamide. Okay. The purpose of this reagent also same to dehydrohalogenation only, but the reagent working procedure is different. So this sodium and this bromine will be eliminated, whereas this hydrogen and this ammonia NH2 will be eliminated. So there will be two things. One is minus NH2 minus NaBr. Obviously, there will be a triple bond between them. C triple bond C. So this is how we had what is the reactant initially? Vicinal dihalide. And what is the final product? We have the alkyne. So we can prepare the alkynes by using the vicinal dihalide. This is the complete procedure. Okay. So let us see about the next one. Now, this I told you adjacent. Okay. Whenever it is adjacent, then it is called as a vicinal. If they are available on the same carbon, see same carbon only boron, same carbon bromine, and same carbon only bromine. So everything procedure wise same here, alcoholic and alcoholic only. But the name it is called as a gem. The name we call it as what? Gem, and full form of this is geminal. The full form of this is called as a, just like vicinal, here it is geminal. And procedure is same. See, but there are two bromines here. There are two hydrogens. Let us take these are the two bromines. Okay. And this is one hydrogen. So in the first step, same whatever we have done there, here also we will be doing same thing. First step is the alcoholic. Alcoholic shows that is elimination. So this H, this OH is eliminated as minus H2O, and this bromine, okay, this bromine and this potassium is eliminating minus KBr. So obviously it is going to give you the product which is C double bond C and bromine here and hydrogen. Now what we will be using? Sodamide, NaNH2. Always remember alkali metal will remove the halogen, sodium and bromine. So minus NaBr, okay, and hydrogen and this ammonia. So NH2 will be forming the ammonia. So earlier it was double bond. Now one more bond will be formed, that is triple bond. So this is the second preparation method from the geminal dihalides. From the geminal dihalide, the common thing is that they both uses the same procedure, which is called as a dehydrohalogenation. Dehydrohalogenation. So by the dehydrohalogenation of vicinal or geminal, we can prepare by using the first step alcoholic KOH, second step sodamide. So this is how preparation of the alkyne is done. Now this is the vicinal, this is the geminal, and both are di only. Both are what halides? Dihalides only. Now we were going to discuss another method instead of dihalides. This time we are going to use the tetra. We are going to use the tetrahalides. Okay. If the tetrahalides are there, the reagent will change. If dihalides are there, then reagent is this. Here, in case of the tetrahalide, the reagent which we are going to use is zinc dust. Okay. So wherever we want the double or triple bond, in that place only total 4 halogen is must. On the same carbon, 2 halogen, and that they should be vicinal as well as geminal. The condition is that vicinal as well as geminal. How it is geminal? See, let me show you here. So these two, with respect to these two, okay, they are on the same carbon, so that's why it is called as geminal. But if I take the reference of these two, with the reference of these two, this is called as what? Vicinal. Okay. So anyhow, the reagent which we are going to use is the zinc. So each zinc wants a 2 bromine. So I will be using plus 2 zinc. Let me write here. So I will be using the per mole of tetrahalide. What I have to use? 2 moles of zinc. So 2 mole of the zinc and 4 moles of bromine. So it is going to be minus ZnBr2. Minus ZnBr2. Okay. So this is the fourth method. Third method, tetrahalides. Okay. In the tetrahalides, the reagent we have to use is zinc dust. Okay. Then let us see about the next method. That is fourth method. Here also vicinal is there, but instead of alkane, it is alkene. Okay. So let me change this. Fourth method is vicinal. Vicinal dihalide alkene. The alkene which have the vicinal dihalide. 2 halogens are must. They must be on the adjacent carbon, and already it should be alkene. So let us take C double bond is there. Okay. And here 2 halogens are must. Both halogen must be adjacent. So when we use the zinc, same zinc, whenever you have to remove the zinc, the simplest reagent which we are going to use is the zinc dust. So each zinc is going to remove the 2 bromine. So as soon as this two bromine are removed, there will be a new bond formation. One more bond formation will be there. So instead of double bond, now it is going to be triple bond. So these are the four related methods only. Okay. Now let us see about the next method. So that is about the calcium carbide. The limitation of this method is to only alkyne. We can prepare what? Only alkyne can be prepared. So let us see here Ca and let calcium carbide. What we are going to use? Calcium carbide. Okay. So calcium carbide, I think all of you are aware that calcium will have the +2 charge and carbide will have the minus charge. So Ca+2 and C triple bond C. So one negative charge here, one negative charge here. Okay. Now when we hydrolyze it, always remember while writing the hydrolysis, water must be written as HOH. So here 2 moles of water are required. How many moles of water? 2 moles of water. How we will come to know? Very simple. Each hydrogen will carry +1 charge and each OH minus will carry 1 minus. So when it is reacting, obviously the positive charge should be how much? 2 units. So this will go and attach here, this will go and attach here, then triple bond, C triple bond, CH triple bond. Okay. So this is what we can say that ethane is prepared. Ethane is prepared. Okay. But this method is applicable only for ethane. Sorry, instead of writing this alkyne, I should write only for ethane. We cannot use for any other alkyne, ethane. But this is the one method which have the limitation. Second method also there, ethane only. Third method also there, ethane only. But we can upgrade and update to the any number for fourth method, by the fourth method. Okay. So let us see about the ethane preparation from the CaC2 is over. Berthollet process. It is no mechanism, no nothing. Very simple. You should remember that 2C plus H2 when passed through the electric arc at 1200 degrees Celsius. Then we will get only product is always CH triple bond CH, ethane only prepared. So here also CH triple bond CH. Next, Coles electrolysis. So here I will tell you the technique when we use the soda lime. So it is going to remove the KOH. It is going to remove the KOH. Okay. So this I am writing like this, OH and H. So what will be the product? Can anybody guess? What will be the product? Nobody can guess. Okay, no problem. So this potassium and this OH will be eliminated. This potassium and this OH will be eliminated. This CO2 will be eliminated. This CO2 will be eliminated. Then this pi bond will come and attach here. Okay. So let us see what is the preparation method of the ethane. Then CH, now double bond will become as a triple bond. So what are the other products? 2 moles of KOH will be the product and 1 mole of hydrogen. Already I told you this method also used only for ethane. Okay. Now because of this, we can increase the number of carbon atom by this. So before going further, let me explain you once again this method. Okay. Now RC triple bond CH. This is what we call it as acidic hydrogen. This is what we call it as what hydrogen? Acidic hydrogen. Okay. Now when you treat it with the NaNH2, obviously, what is the reaction? Not NH3, NH2. Obviously, the reaction will be Sodium will be replaced here. Hydrogen will be removed as NH3. Then it is going to give you RC triple bond CNA. Now let us take, there are only 3 carbon. You want 5 carbon. Then you can give it as a alkyl group R dash. Okay, R dash X. So if you want, for example, total 5 carbon, then R dash will contain 2 carbons. As per our choice of the product, we can change the R and R dash. So then R C triple bond C R dash. Okay. And what is eliminated from here? Sodium, from here halogen, minus NaX. Minus what? NaX. So this is how preparation method is done. Okay. Now let us see further methods. So this is called as a vinyl. This is called as what? Vinyl chloride. There are 2 types of halogens, vinyl and allyl. So here I am writing the next method. CH2. Let us write like this. CH2 double bond CHCl. So directly attached to the double bond carbon, then it is called as a vinyl chloride. It is called as what? Vinyl chloride. Sorry, vinyl chloride. Okay, double bond, on the double bond chlorine it is available. That's why it is vinyl chloride. So here we have to remove this one and we have to remove this one. Whenever one hydrogen, one halogen is to be removed, then what we must use? We must use alcoholic KOH. Good. So in the alcoholic KOH, this potassium and this Cl and this hydrogen and this OH minus will be eliminated. Okay. OH minus. So obviously already there was a double bond. Now we are going to get the triple bond. CH triple bond CH. Okay. So this is how we can prepare the alkyne by using, if only one halogen also there, no problem. But that must be vinyl halide. So this is about the preparation method. Okay. Now let us see about the next one. By using the Grignard reagent. By using the Grignard reagent. Okay. So Grignard reagent CS3MgI. First it will be reacting with CS3MgA. Then whatever the alkyl group you want, that alkyl group can be introduced. For here, for example, what I have taken? CS3 as an alkyl group. Now, same thing, most important one, this is also only for the ethine. This is also exclusively applicable for ethine only. So let me tell you from where we can have ethine only. So here ethine only, here ethine only, here ethine only, and here also ethine only. So 6 moles of the silver. 6 moles of the silver, CH and I3. So another CHI3 like this. I3H CHI3. So in this reaction, what will happen? 6 moles of silver will combine with 6 moles of iodine. 6 moles of iodine. So 6 moles of AgA, 6 moles of iodine will be obviously 6 moles of AgI will be eliminated. So what is left over? Let us count here. Let us count here. So CH triple bond CH. So that is the difference between the preparation of alkynes and preparation of the when you add it to the further, you can make it to the haloalkane also. Okay. Next, let us see about the next method. This is more important. And isomerization. See here, this is a terminal alkene. What is isomerization? Is nothing but transforming the one type of reactant into another. Okay. This is terminal alkyne and this is non-terminal. So whenever triple bond, double bond are available in the last, then it is called as a terminal. Okay, if there is no preference, okay, non-terminal, clear? So terminal and non-terminal, I think, understood. But here, if the non-terminal is converted to non-terminal by using the alcoholic KOH. But if you have the non-terminal, then terminal, then sodamide in pyridine. So these are the preparation method. I think I have covered all of them.